All right, grade 8, we're going to go through the practice set for lesson 101, and it talks about geometric probability. Now, probability we usually express in a fraction, for example, 1/12. 1/12 would be a good example of a fraction that says, what's the probability of that happening? And you say 1/12 or 1/2 or 1/3. So you know that we're going to be working with fractions when it comes to this. So when they ask you, find the probability that an object lands in the larger region, will that lands in the larger region will also land in the inner shape. So when it's looking at the larger region, it's saying it'll land in here, but it will also land in here, in the middle, in the middle section here as well. So in order to do that, what we have to do is grab the area of the smaller rectangle, which has dimensions of 3 and 4, and figure out the area of the larger rectangle, which has area of 6 and 8. So we know to find the area of the smaller rectangle and the larger rectangle, we can put them into fraction format. So 4 times 3 can go on the top, and 6 times 8 can go on the bottom. So you can see that that is 12 over 48. And we can reduce that smaller by dividing by 12, which you get as 1 here, and we get a 4 there. So there's a 1/4 chance or 1/4 chance that if something were to be thrown at this object, it would land in both the larger and in the smaller box. So it would land within this box here, but also within this box here. So that's how that geometric probability works. So if you understand that, it might work well for you to hit pause and then go to B, do B, and then watch me solve that one for you as well. So here are the numbers that we have. We have 10 on the bottom, 10 on the side, and then we have 8 over here for the triangle and 6 over here. So we know that we can put the triangle here and we can put the square over here. So the triangle will be 6 times 8 divided by 2 over 10 times 10, which would be the square, right? So we get essentially 24 over 100. And we know we can divide that by 4, so it will get us a total of 6/25. And that gets us down to the smallest number for that probability. The next one they throw you for a little bit of a loop with. I suggest you try it on your own and then see if you get it right. So we have a larger square and a smaller square. I'm putting the dimensions in right now. And some of you may feel that you have to work at triangles and all of those kind of different things. But remember, we're working with a smaller square and a larger square. So the numbers that we're working with for the smaller square are 10 by 10. And the larger square would be 14 by 14. So if we figure that out, we get 100 over 196. Okay, we can divide both of those by 4, and that would get us 25 over 49. And that's as low as you can divide that, because you can see that those are perfect squares and they'd only divide by 5 or 7. So that gives you the answer to C. D is a little trickier because you're dealing with circles and you have to remember the formulas for circles. Okay, so try it on your own and then I'll give you the solution. Okay, so the area of the smaller circle we're going to have to figure out. We have a radius here of 10, and then we have a radius for the larger circle of, the radius of the larger, I got those numbers mixed up. Let's try them again. So the radius of the larger circle is going to be 10, and the radius for our smaller circle is going to be 6. So let's figure this out now. we know that the area of a circle is pi r squared. So this is a small circle, SC, and the large circle, LC. So pi r squared 2. Okay? And leave pi as pi. So what do we have? We have the radius of the smaller circle being 36 pi, and the radius of the smaller circle being 100 pi. You see I did 6 times 6 here for radius. We left pi as pi, and we did 10 times 10 for radius, and we left pi as pi. But you can see that our pi's cancel each other out. We can divide both by 4 to get us 9 over 25. So the probability of it landing in the smaller and in the larger circle is 9/25. Okay. Moving on to E. Okay. It says, what is greater? This is a little bit different of a question. What is greater? Is the probability that an object lands in the square, or the probability that the object lands in the circle outside of the square? So you can try this on your own first and then listen to the solution. That will give you an idea of whether you understand it. Okay, the probability of it landing in the circle, and then the probability of it landing in the square. Okay, so we have 10 over here, and we have a radius going across this whole thing of 20. Okay, so we're going to do the first one here. We have the square and we have the circle. So the square would be 10 times, oops, let me try to get that neat, 10 times 10, and our circle would be pi r squared. So it is 3.14 times 10 squared. So what do we get as an answer? Well, it'd be 1 over 3.14 as an answer of it landing in the small circle. So if we divide that on our calculators, 1 divided by 3.14, we should get a decimal number. So we go to our calculator, 1 divided by 3.14 equals 0. I'm going to make it a smaller number, 0.32, right? So if we grab whole as being the 1, we go 1 subtract 0.32, subtract 0.32, we get an answer of 6.68. Okay, so that would be 0.68. So that means that if we look at it, the probability of it landing in this square over here would be 0.32. The probability of it landing in the larger circle would be 0.68. So if you're looking at it, there is a greater possibility. There's a greater possibility of landing in the larger circle. So it's grabbing that information that you have and making sure that you have the right details there. Hopefully that makes sense for you. If you have questions, I'll be available throughout the morning for your questions, and we can just hop on the Google Meet that you find in the classroom. Make sure that you do every other one for this assignment. Thanks, grade 8.